Ever wonder how giant banks or investment firms seem to, well, predict the future? I mean, it's this high stakes game, right? Fortunes are made, fortunes are lost. But here's the thing, it's not magic. It's not some cloudy crystal ball. Nope. It's all about science, data, and some seriously powerful algorithms that are completely changing the game. So let's take a look at how they actually work. And that really brings us to the big question we're diving into here. Can algorithms actually predict the future of money? And we're talking about the whole spectrum, from the huge, chaotic world of the stock market all the way down to something super personal, like your own credit score. So to figure this out, we're going to look at a tale of two very different predictions. First up, we're tackling the big one, the massive, massive challenge of predicting the entire market. And then we're going to zoom way in to something a lot closer to home, how algorithms try to figure out if you, an individual, are actually going to pay back a loan. All right, let's jump into our first tale, trying to predict the market's mood. This is one of the toughest nuts to crack in all of finance. For the longest time, it was all about human gut feelings, intuition. But now, well, the machines are taking over. Okay, so to see how good these machines are, you need data, and I mean a lot of it. For this particular study, researchers grabbed 10 years of daily closing prices from Brazil's IBX 50 stock index. Now, look at the chart. Most of that data, the big unshaded part, that's what they use to train the models. It's like the study guide. But that little gray area at the end, that's the final exam. It's the test data, the part the model has never, ever seen before. This is where it has to prove it can actually do what it says it can do: predict the future. So we've got a showdown here between two different approaches. In one corner, we have ARIMA. Think of this one as the traditionalist. It's a classic, time-tested statistical model. And in the other corner, we've got LSTM, the modernist, a much newer, way more complex approach that's all based on machine learning. So how does ARIMA work? Well, it basically looks at past data points to find simple patterns and trends. It's really, really good at looking at what just happened to predict what's going to happen next. You can think of it as having a great short-term memory. LSTM, though, that's a whole different beast. It's a type of neural network, which basically means it's designed to learn kind of like a human brain does. It's built to recognize super complex patterns over much, much longer stretches of time. So if ARIMA has a short-term memory, LSTM, that's got the long-term memory. It lets it see the bigger picture. So, who won the showdown? Well, here's the twist. It totally depends on how far into the future you're looking. For a super short 5-day forecast, the old school ARIMA model was actually more accurate. Why? Well, because it's great at spotting those simple, right in front of your face trends. But the second you try to look further out, say 15 or 30 days, LSTM's long-term memory gives it this massive advantage. It can spot patterns from weeks, even months ago that might affect the future, something ARIMA just can't do. And that's the key takeaway here. There is no single best crystal ball. The right tool for the job completely depends on the question you're asking. Are you trying to predict tomorrow, or are you trying to predict next month? Okay, so let's hang on to that idea, choosing the right tool, and apply it to something way more personal. Our second tale takes us away from the big abstract stock market and right down to a decision that affects millions of us. How do banks use algorithms to predict if you're going to pay back a loan? And you have to understand, for the banks, this is not a casual question. I mean, the official comptroller's handbook calls credit risk a significant part of their business. They have to get this right. It's essential for their survival. Think about it. One bad loan is a headache. Thousands of bad loans? That's a full-blown catastrophe. So how exactly do they do it? When you go and apply for a loan, what is that algorithm actually looking at to decide if you're a safe bet or a major risk? Well, the process for building this particular crystal ball is actually pretty simple, at least in theory. Step 1, you gather a ton of data. You look at thousands of past customers who paid back their loans and who didn't. Step 2, data scientists use all that history to build a predictive model. And step 3, and this is the big one, you test it. You test it like crazy to make sure it actually works. And this is what that first step, the data gathering, actually looks like. When you start analyzing all that past data, really clear patterns start to pop out. So in these charts, 0.0 is for people who paid their loans back, and 1.0 is for people who defaulted. And you can see it, right? The group that defaulted, the 1.0s, they tended to have way more credit card debt and other kinds of debt.
This is exactly the kind of pattern an algorithm is designed to find.
And this is what that model can look like. It's something called a decision tree. And really, it's just a big, smart flowchart. It takes your data and asks a series of simple yes or no questions, like, is their debt-to-income ratio over a certain amount? Or have they had their job for more than a few years? Each answer sent it down a different branch of the tree until it gets to a final answer. Yes, this person is a risk, or no, they're a safe bet. But, building the model is really only half the battle. Now comes the moment of truth. Does it actually work when you show it brand new data it's never seen before? How do we even measure if it's any good? Well, one of the first tests is something called a confusion matrix. The easiest way to think about it is like a simple scorecard. It tells us how many times the model got it right, predicting someone would default, and they did, and how many times it correctly predicted they wouldn't. But most importantly, it also shows us all the times it got it wrong. Now, for a slightly deeper dive, we can look at this, the ROC curve. That straight dashed line going up the middle, that's basically random guessing, a coin flip. The blue line, that's our model. And the further that blue line gets away from the coin flip line, the better our model is. The number you see there, 0.87, that's the area under the curve. And trust me, that is a really strong score. It tells us this model is way, way better than just guessing. Okay, but this next chart is where it gets really cool, because this is where we translate all that academic accuracy into actual real-world value. This is a gains chart. So that straight line, imagine that's you, just randomly picking customers, trying to find the risky ones. It's like looking for a needle in a haystack. The curve lines, that's what happens when you use the model. It's like someone hands you a giant magnet. And that magnet, it leads us to this absolutely incredible number. 90%. So what on earth does that mean? It means this model is so good, a bank can find 90% of all the people who will eventually default on their loan just by looking at the top 50% of the customers the model flags as risky. That's not just a small improvement, that's a total game changer in efficiency. All right, so let's bring our two tails back together. We've seen how these algorithms can try to predict the huge, impersonal stock market and also the super personal decision of whether or not someone gets a loan. So what does all this mean for the new rules of risk? So what are the big takeaways? Well, first, whether we're talking about billions of dollars on the market or a single personal loan, the basic idea is the same. Find patterns in the past to predict the future. Second, it's pretty clear that financial prediction isn't about gut feelings anymore. It's being handed over to cold, hard algorithms. And maybe the most important point is this. We can actually measure, very precisely, how good these new crystal balls are. We can take the guesswork completely out of the equation. And all of this leaves us with one last, pretty heavy thought to chew on. As we hand over more and more of these life-changing financial decisions to these automated systems, we have to start asking a totally new kind of question. When an algorithm denies your loan application, who or what is really responsible?